Hi, folks. Welcome to the review session for Exam 1 in Stellar Astronomy. So what I'm going to do here is run through how the exam works and also talk about what the major topics are, just to remind you what it is we've been going over here. So first up, let's just dive right in. The exam is an online, open book, open notes exam. So that means you'll be doing it kind of like the quizzes you've already been doing, except there are going to be some written answer questions as well as multiple choice. Um, you're going to be given 2 hours to do the exam. So there should be a lot of time because there aren't that many questions. In fact, there's only going to be a dozen multiple choice and 3 written answer questions for the whole exam. So that should be a lot of time to do this. I do want to remind you, if you need a DSPS accommodation, and make sure you let me know so that I can get that set up properly for you. So it's an open book exam, and I know it's always tempting when you see that to say, "Oh, well, then I don't need to study," but that's not really true. You really don't want to be spending your time on the exam looking things up. That gets old fast, and you can chew up that 2 hours pretty quickly if that's what you wind up doing. So you want to make sure that you prepare for the exam as if it was closed book. And that way, with most of the questions, you'll be ready. You'll be able to answer them. You won't have to spend any time digging through. And then only when the places where you really need it, that's where you'll go. You go back to your notes. You go back to the lectures, whatever you need to do there. The other thing to remember with an open book exam is that I do expect it to be your writing. If I feel like this is not something you wrote, if it's something you copied from somewhere else, then I am going to take points off, or I have given zeros for our entire exams in really egregious cases. So, this is a basic academic honesty thing, right? You need to be, what you say needs to be what you understand, not somebody else understands. All right. So make sure you're doing that. Now, um, so the exam is going to cover everything that we have done up to this point. So that means starting from uh, from the beginning of the course, going through scales of the universe and so on, all the way up through matter and light. So all the material we've covered there, including all of the assignments, the quizzes, the discussion, the note-taking questions, the uh, the the constellation questions, the your turn assignments. Those are all the kinds of things you should be looking at and practicing as you're preparing for this exam. Because that's one of the key things that I always recommend here. It's not enough to just look this stuff over. That's fine if you just have to want to memorize a bunch of facts. But you've been learning skills in this class. You've been learning how to how to answer specific types of questions, how to think about things the way a scientist thinks about the world. And so that's a thing you need to practice to get good at. And that's what I always say for on an exam. Practice those questions, practice those constellation questions, take those note-taking questions and just see, can I write a little paragraph on this stuff? Can I answer your turn questions like the ones we've been doing? The more of that you do, the better you're going to be to answer the questions you see on the exam. And that's really the key here. That's where I'm going to be looking for a lot of the questions. That I'm going to be looking at the assignments. I should say there are 2 categories of assignments that I'm not going to be directly asking about. One is the 2 discussion questions, the introduction and then the or 5. I'm not going to ask you to do something like that on the exam. Those are a little more on the side. Those are not, so I'm not going to have you do that. The other is the labs. So I'm not going to ask you specifically about things you've done in the labs. Of course, the things we've talked about in the labs have been connected very much to the things we've been doing in the lectures. So they, hopefully that's been helping reinforce a lot of the ideas that we've covered in the lecture. So definitely make sure you're thinking about the things you've learned there, even if I'm not going to be asking a question about that directly. Let me go through look at the review sheet here. I want to remind you that there are a couple of things that are on Canvas to help you out, prepare for the exam. One is a review sheet. I just updated it with the current year, so that's got that's got a lot of the information about the exam, and it does remind you of the major topics. Tells you what each of the multiple choice questions is going to be about. So there is a specific topic for each one. And it reminds you of a lot of the things that we're going to go over here today. There's also something that's called the discussion answers on Canvas. That's a name I need to update as into the note-taking question answers, because that's really what it is. These are our note-taking questions. I picked out specific ones, namely the ones I am most likely to ask you about on the exam, and giving you my answer for them. Okay, giving you a little one or two paragraph answer on each one. So you've got an idea of the kinds of ideas I'm looking for there. So hopefully those will help guide you. Again, I don't want to see those things just copied right back at me, but it'll give you, it'll let you see what it is, what kinds of ideas you should have in there. So let's talk about the exam itself in terms of the mechanics of it. So as I said, it's kind of like the quizzes you've done. You do only get one chance on this, not two, but it does start out with 12 multiple choice questions, very much like the kinds of things you've been seeing on quizzes. And as I said, the topics are given right on the review sheet. The other thing then are the 3 written answer questions. And the first of those I describe as a review question. It's, as I say, like the note-taking questions. It is where I ask you for something like, explain the cause of the seasons, or describe Newton's laws of motion, or something like that. So it's the kind of things we do in those note-taking questions. And I want you to answer these in your own words. Tell me give me a reasonable explanation. A lot of folks underestimate the review questions. A lot of folks feel like, oh yeah, I don't need to practice that. Yes, you do. Practice those. It really does help. It really does give you much better answers if you practice what you need to do there. The second question is a critical thinking question. And we've seen critical thinking questions pop up already in 2 different formats. One is in the Your Turn assignments. So those are places where I ask you to take the ideas of the class and then apply it to a new situation. And so that's what I'm going to ask you to do here. So you'll have, so it might be an application of Newton's laws of motion, or the way we transfer energy, or the motion of an object in space. And then of course, we also had a critical thinking question as a constellation question. So that RA and DEC question you did, that one also counts as a critical thinking one. So you want to practice those, and you probably won't see exactly the same thing, but as what you've done before, but it'll be similar. All right, and many of those critical thinking questions do involve your constellation files. So on the exam, I'm going to post a constellation file for you. So there will be a file there. So you don't have to use your own. In fact, I don't want you to use your own. I want you to use the one that's on the exam. So you can take that one and answer the question. If it asks for constellation data, you can use the data um, in that file to help you answer that. And then the third question is a calculation question. And we've done 3 calculation questions so far in the course. We've done the travel time question, where you figured how long it would take to travel to one of the stars in your constellation. We've done a mass energy calculation, where you figure out how much mass energy a star has available based on its mass. And then we've done a temperature calculation, a surface temperature one, where you use Wien's law to work out how much what the temperature of a star is based on the wavelengths of light that are produced. And so you will get one of those on the exam. And Canvas the Canvas exam is set up so that it's kind of randomly pick which one you get. So even if you're working with a friend and the friend gets one question, you may get a different one. So that's the way those are set up. So go ahead and practice those again. And if you haven't done one of these, then, or if you did it and you need to fix something, as part of your studying, go back and make those corrections. You will both get the credit, you can still get the credit for it on the exam, right? I don't want to give you the points for this, but also you'll be a lot better prepared to do this on the exam itself. So make sure you do that. You'll be much more ready, and you'll when you see these things on the exam. Now the exam opens up 8 o'clock on Monday morning, and it will run through midnight on Tuesday. So you've got some time, and you can pick what 2-hour window you want to do in that range to do the exam. And so I'll leave it up to you as to based on your schedule. If for some reason you just can't do Monday or Tuesday, please let me know. Yeah, I'd move it to a different date for you. That's fine. But you just got to let me know what your schedule is, so we can make that work for you. All right. Let me look over the review sheet one more time here, or see if there was anything else I needed to remind you of. Oh yes, so for the written answer questions, one more thing to look for there. If it's just text, if all you need to do is just type in words, then there'll be a text box and you can type in the words, and that's just how it will go. If it involves either a calculation or a diagram, then the question will be set up as a file upload question. And that means that you can, what most people I expect will do is they'll write it out by hand, take a picture, and then upload that. And that works fine. If you'd like to do it on the computer, if that works better for you, you can do that as well. But I don't want you to have to figure out how to draw a diagram on a computer. I mean, for some people that's going to be easy, but for many that's a technological challenge we don't want you to have. And that brings up the other thing I want to point out here. If while you're doing the exam, you run into a technology problem, okay? Like the file doesn't upload, or you're having connection problems or something like that, let me know right away. Okay, just send me a message. If you're trying to upload a file and it's just not going through, put that in the message and send it to me. Okay, so that I get it. All right, that way I know. Yep, you did the work. That's fine. There's no question. And you know, I don't want technology problems to be the barrier on this exam. That's not the point. It's not what I'm trying to test you on. So go ahead and do, you know, if you're hitting a technology problem, a connection problem, in answering the exam questions, then send those answers to me directly, and that way I'll get them, and you know you're in the clear. All right, so that's good. So let's talk a little bit then about what we're actually going to be covering in this on this exam. Um, so we've had several different topics here, several different chapters we've looked at, and they've been different sizes. And as a result, you know, the exam's going to reflect that. You're going to see more questions on the bigger ones and not so many on the things that we didn't spend so much time on. The first chapter was about the size and scale of the universe. And that's really a chapter about definitions. Okay, that's asking you, you know, do you know what a solar system is? Do you know what a galaxy is? Do you, you know, and do you know how these things relate to each other in terms of size, distance, and so that. So this is very much uh, about making sure you know what you're talking about here when we're throwing around the basic terms all through the semester. So make sure you know, okay, what's a planet? What's a star? What's a solar system? What's a galaxy, right? And how big are these things, right? How do they relate to each other in size? Okay. You know, our solar system has one star, the sun, and then it has the planets and other small bodies that go around it. There's no other stars in our solar system. Our galaxy, on the other hand, has a couple of 100 billion stars, and this is much, much bigger. Okay, the Milky Way, that's our galaxy. Our sun is one tiny little star in that huge galaxy of stars that we belong to. So understanding those distinctions, and you know, making sure you're using those properly, and knowing about distances. And you know, one way you can look at that is in terms of light travel time, for example. Okay, we know light travels at a specific speed, and a beam of light just takes a few hours to cross our solar system. So that's a pretty quick, right? We could say that our solar system is several light hours across. On the other hand, it takes years for light to get from our solar system to the next star, to Alpha Centauri, Proxima Centauri, in fact. So that's 4 light years away. So light years is a distance that is a measure, but it also tells you about how long it takes light to make the trip. So don't use light years as a time, right? Because it's not. But realize that it does have that connection to time because it's through the speed of light. So, you know, our galaxy, 100,000 light years across. And we did a your turn question about that, where I want you to think about what that means as far as our scale. If you did it right, you found, oh gee whiz, even the more distant stars in my constellation are still actually really close to the sun in terms of the scale of our galaxy, because the galaxy is so big, and it's just one galaxy out of all the many galaxies that we see. And as we get later in the course, we'll come back to that point and we'll talk about other galaxies a lot more. All right, so that's that size and scale. Also tied to that, we did some basic math review, and so you did that calculation of travel time there as well. The next chapter was the motion of Earth and sky. That's how the Earth's motion affects our view of the sky, and so it's really that's a question that's about perspective. It's about it's about thinking about how big, not how big things are so much as as the fact that we live on a planet. Okay, the Earth is a planet, and its motion and through the day as we and through the year as we orbit around the sun really defines how we view the sky. And we talked about how the view of the sky changes as you go to different parts of the earth, whether you're standing at the equator or standing at the poles, and how, as you look over at different periods of time, how your sky changes, how a constellation that's overhead at one time is not going to be overhead at another time. And how that change is going to happen is going to depend on what kind of time scale. Are you talking about a few hours? Are you talking about a few months? It's going to be different. Remember, when we're thinking about that, it's good to have a good diagram. All right. And so look at the diagrams that we did for that. That's especially that kind of top down view of the source of the earth and its motion around the sun really makes it easier to see what's going on here. And remember, constellations don't move, right? Because they're so damn far away. So the constellation, so if you, once you set that up, if you set up that kind of diagram and you've got a constellation off to one side, it just sits there, right? The Earth moves around, this spins and orbits around the sun. The constellation doesn't move. Okay, so that was some of the stuff we did in chapter 2. We also talked about seasons in chapter 2, and the cause of the seasons. Now, seasons are all about the tilt of the Earth. And that tilt effect doesn't mean that we get closer and further from the sun. It means that different parts of the earth are getting more or less direct sunlight because of how high it is in our sky. So that's another one of those things that I might, for example, ask you to do a review question about. I might say, explain how the seasons are caused, and draw a little diagram to as part of your explanation. We also talked about RA and DEC. Okay, RA and DEC, remember, it's just a grid. It's a way of describing positions of objects in the sky. And it's based on the stars themselves. And so a star has a specific RA and DEC. That doesn't mean there's a specific place in the sky, but it does tell you how it moves in the sky and when it's highest in the sky. And so you should be able to use those things. You should be able to say, okay, this is the RA, this is the DEC. Therefore, I'm going to see and this, tell me, this star rises as it sets, or this star is circumpolar, or whatever that happens to be. And when you're answering questions like this, make sure you show how you got there. Okay, so say, I want to see, okay, this is the RA value, this is what I did with that RA value, this is how I compared it to, for example, the horizon angle, or that's DEC, sorry, or this is how, assuming that, we know 0 hours is RA is highest at in late September, and this is my reasoning, and this is how I get to when this constellation is going to be in the sky. If you just put the answer, you just say it's up in June, and you stop there and don't tell me where it comes from, I'm not going to give you much credit, because that's not the point. I'm very much interested in seeing not just what you got the answer, but how you got the answer. So that's what I'm going to be looking for. Okay, we did a very quick look at the process of science and just talked a little bit about, and I want you to have a basic idea about what we mean by things like a hypothesis. You notice there's a whole lot of questions on this because it really was a very, very short chapter there. Then we got into the physics chapters, and we looked at forces and energy and motion and gravity, and that was a real roller coaster ride of a chapter, because there's a lot in there. But some of the key things that we looked at, we talked about energy, okay, and we talked about the different types of energy and how objects translate between one type of energy and another, how a falling body is turning gravitational potential energy into kinetic energy as it's falling, and that's why that's why it's speeding up as it falls. We talked about, we talked also about mass energy. Okay, the conversion of matter directly into energy, and that's not one you see very often, right? That's not a thing we have a lot of day-to-day experience with, but it's very important in astronomy. because this is what powers your stars. And you did that calculation. You looked at the mass of the energy available in your in your stars, at least for the main sequence portion of its life, and to see how much energy it's got. Now, we're going to come back to that calculation again later in the semester, and we're going to use it to figure out the lifetime of the star. And so we're going to take that mass energy and we're going to tie it to the luminosity and get ourselves and figure out how long a star can last. So that's going to be a something we're going to come to again. So keep that calculation in mind. We talked about Newton's laws, all right, and we did and we talked about forces and accelerations, and one of the key things to keep in mind with Newton's laws is that they're very much about acceleration. Okay, acceleration is speeding up, it's slowing down, changing direction. Any change in motion is an acceleration. Just moving at a constant speed is not accelerating. But if you change that motion in any way, that's an acceleration. And when you've got an acceleration, you've got a net force. If you don't have acceleration, like it's moving at a constant speed, there's no net force. The forces are all balanced. So that's the thing to keep in mind with this. We talked about orbits. And orbits, of course, are really important in astronomy. And so the idea behind an orbit, that's a key one I'm going to be asking you about. So remember, orbits are about gravity. An object in orbit is feeling the gravity of the thing that's pulling. So if gravity was the only thing going on, of course it would just fall, right? We know that. You've all just you're feeling gravity, you fall. So what keeps it from falling? It's not another force. It's a velocity. It's just literally moving fast enough that it doesn't quite hit the ground in time. So the guy behind me here in the picture, he's falling under gravity, but he's also moving into the picture at 8 kilometers a second. And that's so fast that by the time he falls down to where the ground was, the ground isn't there anymore. The earth is curved away from him. And so that's why he never hits the ground. So orbits have two parts. They have gravity pulling you down, and they have the velocity of the object they're orbiting that is what keeps it from hitting the ground. So that means that how fast you have to go to be in orbit depends on how strong the gravity is. If you're feeling more gravitational pull, if somehow we were in this picture here, if suddenly the Earth got more gravity, well, he better have more speed. He better speed up, because if he doesn't, he's going to hit the ground. So the gravity that matters here is the gravity of the object that's being orbited. And most of the time, there's sort of one main thing that's being orbited. Occasionally, like we'll see situations later where you actually have two bodies that are almost the same mass, and then it gets a little more complicated. But most of the time, there's one big central body, and it's the gravity of that body that matters. His gravity doesn't matter. He's too small. It's not a factor. It's all about the gravity of the Earth is what determines how fast he has to go. And that's why he orbits at the same speed. And when they took this picture, he was in the space shuttle, and he stepped out of the space shuttle. He was using this cute little jetpack thing, and he was traveling around separate from the space shuttle. But he was orbiting around the Earth at exactly the same speed the space shuttle does, because his mass and the space shuttle's mass don't matter. They're too small. It's just the Earth's gravity that determines how fast he orbits. And that's why. And the same is true for example, the moon. The moon's mass doesn't matter in its orbit around the Earth. It's really just the Earth's mass that matters. Okay, so that was the gravity and orbits chapter. And we've done lots of different questions. We've done a few different questions about that. We did some stuff with Newton's laws, but we certainly have done, we did a question where I asked you to think about, well, how does the mass of an orbit of a star affect the orbits of the planets going around it? And so that certainly is a fair game kind of question I might ask you as a critical thinking question. Okay, then we did the light and matter chapter. And we talked about the basic structure of matter, like the atom, the structure of the atom, and that's certainly something I might ask you about. Just what are the pieces? Okay, atoms are made of just 3 pieces. Okay, protons, neutrons, electrons. Look around you. Everything you see around you, that's what it is. It's just protons, neutrons, electrons, all combined in different ways, which is kind of an amazing idea. But it's also a very, very cool one. It's a wonderful simplicity to it to produce all this complexity around us. It's something I always enjoy. So and you want to understand that the properties of the protons define what the chemical element is. The electrons, they're kind of the little lightweight fluff around that. Neutrons just help add a little mass to the whole thing. And we'll come back to this because neutrons also have another important role. We'll talk about that a little later when we get to the interior of the sun. Light is so fundamental in astronomy. I have a friend in physics who likes to call astronomy the spectator science because, let's face it, there isn't a lot we can do here on the ground. We have to sit and watch. We have to look at the universe and let the universe show us, which means that we're dependent on light to get our information to us. So you want to make sure you understand some of that. That's really what this chapter is mostly about, is how does light interact with matter? What are some of the ways that we can get information from light? What are some of the things light can tell us? We've seen that. It can tell us temperature, for example. It can also tell us about composition using the spectra. And so these are so light's really key here, and will be a lot of what we're going to be doing later on in the course is going to be about interpreting the information we get from the light from different objects, and both the strengths and the limitations of that are what define what we can and can't do in astronomy. So that's why this was a really important chapter here. Okay, well, that's it. Those are the major topics that we've covered here. Just a quick reminder, if you have questions, please send me an inbox message. Let me know. Glad to work with you on things here, especially if you're working on practicing one of the assignments and you're not sure how to get the answers, or you're not sure what my comments are telling you on it. Go ahead and get in touch with me. I can be happy to either do email exchange or meet online, and we can talk things over. I want you I want to make sure you've got the ideas here. You do need to do the exam in the next couple of days. There aren't any other assignments, but then after the exam's over, we will be doing a few things, not the full suite of assignments we do most weeks, but there are a few different things we will be doing for the rest of the week. So make sure we do have a quiz, we do have some note-taking questions, and we do have a discussion question for the coming week. Make sure don't stop just because you get through the exam. All right. Thanks very much, and hopefully see you online later.